So today we'll continue on from the lecture back last Thursday, and moving on to the concept of collection, and further along how to handle things like exception, which is one of the like basis of many things that you would have to do in programming in the future as well, right? And before we begin, because we have a quick break, well, like 1, 2, 3, like 3 or 4 days between the last class and now, right? So let me do a recap. Because we first of all introduced a new concept about mutability versus immutability. And at this point, right, if you haven't realized by now, you better realize that you can modify the list, right? You can append things to an existing list, or you can create a new list. What does it really mean? It means that if I map a name, right, is a name to a value. If you assume immutability, right, the name is forever mapped to this particular list, and this list is not changing. That's why we call it immutable. In C, in Java, if things are mutable, you have a pointer, right, that maps to a list. Then you put something to the end of that list. The pointer still point to the correct modified list. And that's not exactly what it was called true in Scala, especially when we assume immutability, right? And generally, we have a construct to build a compound data. And accessing this, right, you can actually basically read the content, but you can't modify it, right? It's an assumption when you have immutability on the data piece, any piece of data is you cannot really modify a piece of data once you built it. You can only read from it, and you can create a new object, a new piece of data from another separate older object, right? So that's a concept of mutable versus immutability. And there are some benefits. For example, you can kind of prove your program. It's actually a lot safer if you think about it, because no one can modify my data. If I need to modify the data, I just create a new data, right? We go through some examples last week. I'm not going to go through it now. The next topic that we learn is, hey, we have compound type, right? Things like tuple or things like a list. So let's generalize that. And in general, if you look at your program, there are basically 3 types of kind of like compound data, basically. The first type is called the product type. Think of this as tuple, right? Where you already know at what position what data is going to hold and what are the types of data. For example, a tuple, you need to kind of declare every time. It's going to be a pair of int and int. It can be 3 items of int, string, and integer. It can be 4 items of boolean, and boolean, right? Another good example that I would say is like basically a static array. It has a certain size, you know what goes into them, right? Another type of compound data is something like an option, which is one-off, right? You can take a sum type and look at it, and you realize that the sum type only have one single item, only one thing in there, but it can have many types, right? Option is one of them. You can have a type none or some of a type, right? Another compound type is what we call a recursive type, which is basically the object makes a self-reference to itself. What does it really mean? It means that you can keep growing this item, right? You can keep growing because it refers to itself. So you can add things to it or delete things from it. An example of this is a value of type T can refer to another value of type T, something like a linked list. I have a list that point to the next object in the linked list, right? When we talk about type alias really means you can define your own type, right? And here's an example. I can define a type for person, which consists of 4 things. It's a tuple that has 4 items in it. It's a string, double, int, and string. And this can be annoying, so we talk about record, right? Because over here, if you use type alias to create a tuple, it has to have this strict ordering of what goes into which item in your tuple, right? In this example, you have four things. You have to kind of know that the first thing is the name, then height, then age, then address, for example, right? Which means that you're handing this code to your friend will basically yell at you like, okay, what am I supposed to insert for these things, these four things, right? Unless you actually make a properly commented code so you know and tell your friend exactly, okay, what do we put in for the first input and second input. But you can kind of help, basically help the programmer who picks up your code by using a record. Basically, is think of it as an object or a class, right? It consists of many things that you predefine with the name and the type associated with this name. Basically, the unique thing here is you have the name of the input as well as the type tied to it, right? And this example basically make a record for the person. And to use a record, right, you can just call something that looks similarly to a typical object-oriented programming constructor, right? Anyone here used a constructor before in Java and Python, right? Basically, you can create a new object and have this initialized, right, to this kind of thing. And you can bind a name to a record using the keyword val. Val basically means I'm going to define P1 as a person that consists of John as a name, 180 as a height, 30 as an age, and Thailand as a address or country, right? You can use the field name, which is the dot thing, to access each individual field. And here are some examples with the deck of cards, right? We go through this last week, so I'm just quickly go through them. You can say trait. The trait keywords basically create the, over here is an example of creating a sum type, right? The sum type means that you have a playing card. It can take any type here between the jack, a queen, a king, and ace, or just a number, right? And you can mix up both the class and object in this sum type. And that's basically the concept behind the sum type, because it can take many forms based on your definition. All right. Now that we talk about the recap of Thursday, let's move on to the new topic. Right now, I'm going to talk about this thing called enumeration or enum. In Scala, we can use the trait for enumeration. And here are some example, right? This is basically the same thing we've seen. So let's say you want to define a direction, right? And it's a type that define, you can go north, south, east, and west, right? You can go northeast, southwest, or those direction too, which means that you would extend to 8 different objects, right? This is basically the same as calling public enum direction, north, south, east, in Java. So have anyone seen this before? Oops, my bad. I need to use a pen rather than a pointer. Anyone seen this before or used this before in Java? So yeah, okay. So basically just kind of declare a new data type. Now I can call use the keyword north as a part of direction, right? What does it really do in terms of programming language? It basically gives the programmer ability to define new data type, right? And it also gives you ability to kind of group the data type together. Basically, whenever someone refers to north, you have to tell, hey, it's a part of the direction, right? It's not the north in terms of, like, I don't know, like geology, right? So this is direction north. And with this, you can do complex pattern matching, right? You can do, for example, extract like the first 2 elements of the list into this particular example, right? So with the compound data type, recursive data type, and everything we've seen so far, the concept of pattern matching can be pretty powerful And over here is one example. Let's assume our list will contain at least 2 items. What will this do? These basically would extract the first 2 things in my list, right? It do pattern matching, A and B, and I don't care what comes next. It can be an empty list, it can be any list. Then I'm gonna return a pair A and B. And that's gonna be mapped to first and second. Yep. Please be aware, pattern matching will give you warning if you don't cover all the cases, and obviously, anything fewer than 2 items will not match here. So I'm gonna give you a warning, and will fail when you try to compile because like basically Scala is like, I don't know what you want to do when your list is empty. So be careful of that. You can use if inside this case thing, right? For example, if case n, I just want to check n. If n is greater than 100, do this. If n is greater than 10, do this. Otherwise, do this. You might see in this example before if you look at system skill. It's actually not exactly in Scala, but we ask you to write the script to check the file size, right? And if it's greater than some number, print is huge, it's large, it's medium size, or it's small. It's a totally different language, but something similar. You can use pattern matching in Scala this way. Put if else, tie that to the case you want to match. So remember our minimum function that we did last week, the better min and the not so bad, I think it's called bad min, right? Where you have a way to compute minimum, but the bad min function basically called minimum twice, which is a waste of time. And then the better min has some initial negative, no, actually the positive maximum as an initial value for our minimum value, right? So that's why we introduce the concept of an option. So let's rewrite the function to extract, right, the minimum number in the list. This is what we can do with pattern matching. This is kind of like a cheat because we do math.min, right? But if you do pattern matching, and at the end of the day, you then realize you can do match these 2 cases in the beginning. The first case, if list is empty, return none. If list has only one thing, return just that one item. Otherwise, you can, if list is basically more than 2 items, right? More than 2 items. In this case, call the minimum on the smaller list, or you could do math.min as well. Basically, this is a shorter form with the math.min to actually get the rest of my list, right? The rest of my list, and find the minimum. My bad. All right. So these are more usage of pattern matching and collections. The next thing I want to teach you, and I forgot to do a slide break, but this is a new topic. We call this a polymorphic types. Anyone here want to give a definition of polymorphic? What does polymorphic mean? What does it mean for anything in life? It doesn't have to be in computer science. What does anything, where I say polymorphic, what does it mean? It can take many shapes, it can take many forms, right? It can morph into one thing or another, right? Basically, is I don't know. It's like when you want to describe an object, it can take many forms. Okay. In computer science, right? Given, let's say I have the polymorphic type. Don't look at the text here yet. I go too early. Polymorphic type basically means that I have a data type, but I want to make sure that it can relax from integer to floating point to a double. I want to use this variable as any types that I want to use later, right? And here's one example why this can be useful. Let's say I have a list of integer. and I want to return position k. Basically, I have a list. I want to get the kth item, right? Simple, right? This is basically the function. I go through my list, count from 0 to k. Once it's k, you return, right? This is basically what I want to return. This is my list, and let's say k equals 2, it would return this particular object. That's all, right? And right now, k is integer, and our list is a list of integer. So let's say in an assignment, I keep asking you to do the same thing for integer, string, double, what else? Tuple, pair, every single data type that I can think of. Anyone here would curse me and kind of like tell like why what's the point of that assignment? Right? I mean, likely, yes. I just want to get the k items in my list. Why do I have to kind of implement 10 different functions? Right? Because you have to declare the data type in the list and define a new function. Anyone here has a question so far, by the way, on why can this be annoying? Okay, I'll take a long pause as a yes. So in functional programming, you have to declare the type in a really, really strict way, which means that if you want to get the case item in the list, even though this has nothing to do with the data type of your list, you have to make sure you create a function for a list of integer, a list of string, a list of double, a list of Boolean, right? And it means that you have to do a lot of copy and paste. This means two things. This is annoying, and this is bug prone. If you do copy and paste, there can be a chance you have copy and paste bug, right? You copy something, paste it, and you forgot to change the thing you just copied. The polymorphic types come to the rescue. Basically, this address this particular problem and make the whole program much more powerful, right? And here is the example. Basically, you can first declare a generic data type. Let me just call it A, right? This is a type I call A, right? I can define it that way. It's a generic type, right? Then in the nth function, right, you can write this. Now I switch A to T, my bad. Basically, it can be A, it can be T, any variable works, right? But the nth function would take in type T, which is a list of T. T can be any type, and it return T, my bad. It basically lists of any type, and I'm going to return that type, right? And then I'm going to do the counting up, go to the case element. It can be integer, it can be a floating one, it can be a double, it can be a string. I don't care. It can be a pair of int and string, it can be another list. I don't care. It's the type T, it can be any type, right? And basically this code and quick thing, this should be the letter T because it should be the same type as the thing in your list. But this code basically expand a list. I don't know what's wrong with the slide here. I have so many typos, my bad, on this particular slides. This code basically expand a list of elements, each with the type T, generic type. That's why we call it polymorphic types. Then it would return the case elements of the same type, right? And any questions so far about this code and why this would basically address a problem where you don't have to copy many things over and over and over again? Yes, no? Can I go ahead? Any questions so far? Anything that confused you? I don't mind explaining the whole thing again in a better way. How is that useful? That's a great question. So sometimes you just want to deal with the for example, this is actually a good example with the nth item, right? Uh, does the program behave the same way? Basically, regardless of the data type. Is that a yes or a no? And that's a yes, right? Basically, I just want to get the case item in my list. I don't care, is that an int, is that a string, right? If you don't have the polymorphic types, it means that if that list is an integer, you need to call the function built for integer. If that list is a list of string, you have to call the function specifically built for the list of string, which means two things. First, you have to make many copies of the same function, one for integer, one for string, one for a pair, basically one for each of the data types you might be using in the list, right? The second annoying thing is you need to know which function you want to call. And yes, basically your comment is correct. Basically, now we build a function using this generic type. And we can use it for anything as long as when we use it, we define what goes into the list, right? And that's basically solve our problem because the function has nothing to do with the data type. It's just a collection of objects. I want to return that object, right? So that's why polymorphic data type can be useful in this case. It basically give the scalar ability to say, hey, that thing can be of any type my function would work. Right? I can throw in a bunch of strings in the list and it would work. I can throw in a bunch of integer in the list, it would also work. It would behave the same way, right? Another example is I want to do a SIP, right? The last, no, I think, wait, license class exercise also has a SIP, right? But we can use the concept of polymorphism for this SIP function. And to be honest, this is your solution to in-class exercise. Actually, it's a better solution because it works for any data type. Right? So you can take this and submit the code as well. But basically, this is what you can do, right? Default question mark 3 times. Basically, this should not happen. Do whatever you want with it. Basically, just put whatever you want when this default case happen. Otherwise, if you have two lists, list A and list B, right? The list is list of A and list of B. It basically means that list XS contains data type A and list YS contains data type B. They don't have to be the same type, right? They don't have to be the same type. And it returns one single list that has a pair. It's a list of pair. The first thing is A, the second thing in the pair is B. You just basically plug in the list XS and YS, right? The rest of the code here looks the same as the in-class exercise. Looks the same. You take the front part of XS, the front part of YS, put them together, right? Put them together into X and Y here, right? And then you append the whole thing with zip of the rest of your list because you do pattern matching right here. X right now is the head of XS. My bad. I should use a different name. So you see, anyone see a problem with my code here actually? Can you detect a bug in my code I just listed here? So that's a good question. Basically, this is the head. Any problem with the tail that I just defined? Because basically we do pattern matching on XS and YS, right? Basically we do pattern matching on XS and YS. The problem is the name conflict. Basically I use XS for two things and I use YS for two things. Whenever I put in XS here, right here, which one of XS am I referring to? Well, it can be your input list, right here. That can be the first thing I can refer to. But it can also be this pattern match the tail of my list, right? Do you get it? Basically, whenever I use XS, let me use a different color here. Whenever I use XS over here, right, that XS is ambiguous because your input, you name it XS, and after you do pattern matching, the tail of XS is also called XS, which is buggy. So I would have to modify this code, right? So let me erase everything. And this is what I'll do. I'll just call this XST, YST. T stands for tail. Yes, it will give an error. I believe it will give an error, but there's a small chance because I haven't checked. So please do check. There's a small chance it would actually pick the last name you define, but I'm 99% sure it's gonna give you an error. So I know that's not the perfect answer, so sorry about that. We can figure it out in class exercise actually. So over here, XS is our input list, YS is another input list. We do pattern matching into X and XST. X is the head of XS. So basically XS is something like this. X and XST. YS is going to be something like this. Y and then YST, right? Basically, then after we do pattern matching with this line, what you do is you do a pair XY, return a zip of the rest of the tail for both lists, right? And with this, our example used the concept of polymorphism. Let me switch the ink color back to red, right? Over here, you notice that a list XS who have the type A, any type, it can be integer, string, or whatever. List YS can be also any type. You just need to make sure when you return, the left side of the pair is the same type as whatever goes into the first list. The right side also has the same type as whatever goes to the right side of the whatever goes to the list YS. And this basically same thing works for case class, case object. And we'll get into this later when we talk about object-oriented programming in functional programming. Right. So any questions so far? All right. If not, feel free to keep typing in the question. Right now, I'm going to move on to the next topic, which is different operation. This is one of the really useful operation in, I would say, computer science, actually. This is called folding. Folding, actually, it's almost the same as when you fold the clothes, right? So you do laundry. At the end of laundry, you have to kind of fold the clothes, right? Rolling thing over, not rolling, but you kind of like fold it, right? Um, this is basically the process iteratively, right? So I'm gonna break this sentence down for you. The first thing you have to look at this folding operation is it's gonna be iterative, doing over and over and over again. That's the first thing you do. What do you do when you have to do things over and over? You apply the operation over and over and over on everything in your list or in your collection, and then you sum up the results. So that's 4 steps basically. Repeat doing applying the operation. So I'll put it this way. Apply the operation on every single thing in your list or your collection, accumulate the results, repeat it over. 4 steps, right? Apply operation on everything in the list, accumulate the result, repeat the process until you're through the list. These operations called folding. Any question on the high level explanation here before we dive deeper into some examples? All right, so here is one example. Let's define a function called foo that takes an input list This is the list. I don't have enough room to type everything so that it's going to be syntactically correct. Our ST is our list. This is our kind of like accumulator. Basically, it keeps partial results. It's going to keep partial results, right? It starts with some initial state. And you keep doing this operation on every single element. Basically, this is kind of like almost like a Python code, right? This is a pseudocode, is not in Scala. Again, this is not in Scala. For elements in my list, I'm gonna run this. Accumulate state will apply a function. Basically, this is a function you want to apply. And you keep collecting the results. You apply the function on the accumulation of that result with the elements, with the current elements, and you return the result of that operation. You can do this particular operation in Scala by calling this xs.foldLeft initial state, that function. So let's say my list is 1, 2, 3, 4, and 5. What will happen if I do this xs.fold left initial state is 0, and I just want to do an add. Basically, I'll have to define a function called add, which is basically take two input and add the two numbers together, but let me just write it that way. What will happen if I do xs.fold left 0 and add function? What will I get from 1, 2, 3, 4, 5? So the first iteration, you start with 0. 0 is my initial state, right? My initial state. 0, what's our operation? What's the function I'm applying? Add, right? You want to add something to 0. What's the first element in my list? 1. So you're going to get the first iteration, 0 plus 1. You get 1, right? The next operation, apply the same function. Add, what's my initial state? What's my updated state? I have 1, right? 1 is my accumulator. So I add 1 to what's the next element? So I ask 1 plus something. And what's that something? What's the next item? 2, right? So it's 1 plus 2. That's 3. So what's next? I have number 3, which is my accumulate state. The operation is add. So I do 3 plus the next item. The next item in this case is 3. So you get 6. The next iteration, 6 is my accumulate state. So the 6, my operation is add. So 6 plus what's the next item after 3 in my list? 4. Yes. So 6 plus 4, that's 10, right? And then you do the same thing on the last item, 10 plus 5, 15, and you're done. Basically, that's it. That's the end of my list, so you return. What will you return at the end? If I do xs.fold left 0 plus, what's my results? 15, right? Basically, that's 1 plus 2 plus 3 plus 4 plus 5, right? You add everything together. And this is really, really, really simple example just to show you that you can do it this way. xs.fold left 0 plus. Basically, that would apply summation on your list, right? This basically means that if I do xs.fold left, right, you start with the list xs, then you accumulately perform this function called do magic to each element of xs from left to right. There's this thing called fold right as well. Fold right means that you start from the right side to the left side. So this is kind of like the operation that's available. Okay. And a quick thing, I totally understand if this sounds confusing for you. The first time I have to play with folding in a real assignment because it would get a little bit more complicated, right? My simple with summation is easy. It's easy to follow. In a real thing, sometimes you have to do folding in a way that's complicated. You apply two functions, like what the heck, right? Or you apply this on, say, a pair of lists, how you're gonna have the initial state. So with practice, it would help. With practice, it would help. Basically, if you have questions or stuck on something with folding, let me know. Basically, this apply the same operation again, again, and again, and again, and you accumulate the result. All right. Now, we talk about folding, we talk about operation, we talk about enum, we talk about polymorphic types. What else do we have to cover so that you can kind of finish assignment one and kind of like be done with basic functional programming before we introduce more concepts about what else go into a language? I'm gonna talk about the rest of what collection like, and actually it is more like exception. So I think I should change the slide title to exception. Uh, anyone use exception before in Java or Python? Awesome. So if you did, I believe you have done it before. It's actually the same concept. Yay. Learning new things by not learning new things is awesome. Uh, why do we want to handle exception, right? Sometimes you want to make sure that your program do the right thing, basically. So if I have to access a list and somehow your input is an empty list, right? Or I just divide by zero. How many people make a mistake of trying to divide by zero when you run a program? Raise your hand, including myself. I'm raising my hand. I did that many, many times. It happens, right? It's our nature as a human. We can write programs and we can write program that's buggy. Even a large company can write buggy program. How many of you notice like once or every other 2 years sometime Google would have something crash? I mean, it does happen. Sometimes you have a buggy code. Uh, another story that I've heard, I'm gonna go tangential thing here. Another story I've heard is like many of the startup company, including a well-known company, like for example Facebook, right? Sometimes they take in interns during the summer. And one great thing about this company is that they actually give the intern the ability to check out some of their code related to the team that the intern is working on, right? And what can happen with interns? They can break by accident, break things, right? The first time you see the code, you thought this particular line of code is supposed to do certain things, but you were wrong. So Facebook can go down for like 5 seconds because of interns. It, I believe it does happen. Uh, and that's the nature of our career. We are programmers, we break things and we fix it afterward. Make sure we fix it afterward. But exception is designed to handle that. Anyone here seen HTTP 404 before? What does HTTP 404 mean? Yeah, it is page not found. Basically, this is basically the description is page not found, right? The 404 is basically is an error code. Is an error code that would describe, hey, I tried to find this location in the internet and I cannot find it, right? Like this page not found. And the thing is, this number generally is the number that the whoever developed this HTTP protocol to tell everyone who uses it that, hey, if you see this error code, it means that the page you're trying to access is not there, right? And basically, this is how a program conveys something is wrong. Right? Is how you can convey something is wrong inside a program. And it's the built-in features of many languages, right? It's many languages have this kind of support. Anyone here want to give an example of a language that doesn't really have a good exception support? That you might have actually learned it before in some of the classes we're teaching here? Anyone here took system skill before? All right. Anyone here heard of this language called C before? Yeah. So traditional C languages are kind of designed without this error handling support. Basically, you kind of there's no direct call exception, something goes wrong. Basically, the program would actually yell at you while you're running. And most of the time, the thing that yell back at you is the OS, the operating system. You run it on Windows, Windows will yell at you. You try to do something dangerous. Something is wrong here. And when you write program in C, one of the most common thing you can run into is this thing called segmentation fault, right? If you took system skill before, you are likely sick of it by now. This is another way to kind of like raise that something is wrong. And this is kind of like the concept behind exception, which is basically, hey, let's have a better way to tell the programmer something is wrong. And also tell the user, but most of the time, make sure the user don't see that, right? And in Scala, we can use the keyword throw, right? Anyone here use the keyword throw in Java and Python before? Awesome. So several of you do a thumbs up. I assume that this is cover. Same concept. Yay. Throw new exception name. This is how you use it in Scala. So this is basic learning by not learning. You've seen it before, same concept. The new thing that you have to a little bit be careful is functional language is they cares a lot about the data type, right? So the thing is, exception now has a data type because Scala somehow is a strongly typed languages. Everything should have a type. So exception would have a result type. For example, uh, if I do this, I would do pattern matching, and I want to get the head of the list. Basically, that's the only thing I want to do in the function. I return the head of my list. What can go wrong here? The only thing that can go wrong is your input list is an empty list, right? So if your input list is an empty list, you can throw a new exception called well, basically now it's a runtime exception, and right now you just say print to the user XS cannot be empty, right? That's it. In this case, the exception would be correctly typed as the type of XS. Right now, let's say XS is a list of integer, it would be correctly typed as an integer. This new exception you throw is an integer. Why is that the case? Why is that the case? Over here, your function here basically return the type T, right? This is type T. This also has to be type T to make sure it's correct. That's why exception handling is being typed as the same type as the results, right? Otherwise, Scala would like, oh, I don't know, this thing doesn't have a type and it's not safe. So by default, it would actually be applied the type of whatever you're supposed to return, or when you have to throw that exception, that's going to be the type of your exception. All right. So if you develop a program and you run into an exception, what do you usually do? What do you usually do? What are the options of things you can do when you run into exception? Well, obviously. Anyone ignore it before? Your program crashed and it's like, hey, I'm not gonna do it now. Cry in the corner. And like, oh, too much work, I'll do it tomorrow. And it crashed. Basically, you crash your program. Is that an option? It is, right? Uh, since now everyone is in a lockdown, how many times Netflix crash on you? Zero. That's awesome. Sometimes Netflix can run into exception, right? For example, it try to like connect to the internet and somehow my internet sucks and I'm not able to actually properly log in with my account and say, hey, I can't really log in because actually I can't access the internet. It's kind of there, but internet is too bad, like bad enough that Netflix thinks that it is connected, but it's not connected, right? So one of the things you can do with exception is to ignore it. This is actually one possible option for you. Why is that good? Why is that good? Basically, your program can be pretty dangerous if you keep the exception going, right? What will happen if I have a divide by zero exception and I don't crash that program? I keep it running. What will happen? Yeah. Well, yeah, all of them are correct. All of them are correct. Yeah, everything here is correct. Basically, it will go into this undefined behavior territory where I don't know what I'm doing, right? I don't know what I'm doing. And this can be dangerous if you're looking at any example of a program that can kill people. All right, anyone here heard of this thing called, yes, airplanes? That's an awesome example. Anyone here also heard of this medical robot? Another great example. Self-driving car, great example. Tesla crashing into random things, another great example that actually happened multiple times, right? So when the programs run into the unknown territory, it's better to stop the program from running sometimes, right? If you think about it, hey, well, in the airplane cases, maybe don't crash the program because that's even worse. But maybe if it's just an OS, right? If it's just an operating like Windows or Linux, how many times your Windows crash and you just reboot? I mean, happened many times with me, right? The blue screen. That's why it's a running joke. Whenever we call it blue screen of death, basically whatever you're doing, you lose all the thing you're doing. It somehow Windows just reboot. RAM just filled up. That's another great example. This is not exactly, somehow it's actually not caused by exception. Somehow that's basically, there are two things. The first thing is sometimes you have this thing called memory leaks, which means that you occupy a lot of space for your object that you created. And when you're done using those objects, you forgot to free them. So this is called memory leaks and it will keep eating up your RAM, right? Another instance is sometimes, well, there are two things. You can basically have a machine that only have limited RAM. And the program that you're running assume that you have to have more RAM than this because it's going to keep asking for more. So your RAM fills up. The other instance is sometimes you just write inefficient program. So one of the sad facts about I guess computer science nowadays is you write a program for the features, basically implement it for your clients and you're done, right? Anyone here implement a program and thought about how much memory have I been using? Not a lot, right? But you have to actually think about it, especially with the modern day age application like IoT. You have a device that has only like say 4 kilobytes of RAM or 8 megabytes of RAM. So you have to actually be careful what you put in there because you're gonna run out as you mentioned, right? Sometimes your RAM just fills up. And what will happen? What generally will happen when your RAM fills up? What's the first thing you're gonna feel when you use a computer that has a lot of filled up RAM? It's gonna be laggy. It's gonna be really, really slow, right? The reason why it gets really, really slow is what's the next available storage element in your computer after RAM? So yes, hard drive. Yep. Basically, you have the hard drive in your computer. That's the other thing you can store data on, right? The sad part, DRAM takes about 50 to, I would say, depending on how crowded it is, it can be like about 40 nanosecond to about 200 nanosecond. If you look at GPU, that's go to 1000 nanosecond easily, but still within nanosecond range, right? Within nanosecond range. If you go to hard drive, you're talking about microsecond. An older hard drive, you're talking about millisecond. So microseconds, milliseconds, 1000 to 1 million times slower. That's why your computer starts to be really slow because your data is not in the RAM. It's actually in the hard drive, and you have to go all the way there, right? Another analogy is like, let's say I want coffee, and somehow in Thailand there's no coffee shop anymore. Someone took out the coffee beans, and somehow I need to fly to what's the closest place that have coffee. I guess Indonesia allows, and get back to home. Right, it would take a long time. So this is basically the same thing that happened when you run out of RAM. That's why it's gonna be so slow, right? And you can kind of like, well, I'm not sure exception can solve the incompetent programmer problem. So, uh, maybe I use a strong word. Basically, a programmer that doesn't really think about how much memory he or she has been using, right? But it does fix a problem when you have weird behavior, like divide by zero. You can throw it, you can ignore it. When you ignore it and have the exception, it means it's gonna crash the program, which is good. It's okay. It's good to crash rather than run it in an unknown territory. The second choice, you can try to catch and handle this. Basically, exception is about catching all the edge cases that are unexpected, right? So you can do this thing called try and catch. So you've used the throw keyword before. I'm sure you've used try and catch before. Am I correct? All right. So what does try and catch do? Basically, the gist of it is if I try this thing I circle in red is basically it's the thing I'm gonna try. And when I try it, sometimes it might have exception. And if it indeed has an exception, this is what I'm gonna do. I'm gonna try to cache it. I try to cache it. And if the exception, for example, match this case, right? The exception that got thrown is arithmetic exception, for example. I'm gonna return this. Because I know if I return 0 and 0, it's safe, the program will keep running, it's fine, you don't have to crash the program. So you can use try and catch to actually catch the exception and handle that, right? Catch an exception and handle that. This is basically two completely safe way to handle exception, which is basically undefined behavior that you have to throw and kind of inform the programmer. Sometimes exception are parts of the design you haven't thought about yet, so you have to kind of cover it later. Sometimes it's the edge cases that you know that you can just say return 0 and it's fine, right? So hopefully this is kind of similar to you've seen in Python and Java before. So I'm going to move on to the other use of exception. So let's consider this function, right? Let's consider this function. And this is basically a kind of like a good trick we can do with exception. So what does exception do? Actually, let me ask you one thing. What is basically when exception happen? What's going on in a program? It stopped running, right? So first of all, it stopped running, and it would basically throw the exception. With me so far, basically, when you see an exception, whatever function you're in right now, you stop. Yes, no, and you throw the exception, right? So same concepts can be used as a trick. For example, I create this function, right? You iterate to a list. Basically, this function iterate through a list. Iter_find is find the match, right? And my bigger function here, find last, is I have the input list xs. I have a list. I want to search the list for a key. Basically, I want to search the list for a value int called key. And once I find it, I'm gonna return. But I want to return the last occurrence of that key. Right. Basically, I can have the list as 1, 2, 5, 3, 5, 9, right? And let's say the key is 5. It would return this last occurrence of 5. With me so far? It would return the last occurrence of the number I want to search. Yes, no? With me? That's kind of like a human language explanation of this whole function. Find last is a function I'm going to call to find the last occurrence of the key. Iter_find is basically it's a helper function that I use and I use it in a tail recursive way. It's a tail recursion that will keep iterating over my list and find that last occurrence of the tail thing. All right. What if I call find list of 1, 2, 3, 2, 4 to 5 and 2 as a key? It's going to be a long call, right? Basically, you're going to do a lot of calling function over and over. This is recursion, right? So this is going to be a long recursive call. The thing is, once you're here and you exhaust the list, once you're here and you are done with the list, basically you can return right away, right? You have function call over function call over function call over function call, function call, long function call, right? And you're here and you say, hey, I found it. I found the item I want to search, right? What will happen in general when you found the element in these long chain of function call? What do? You return, right? Which function do you return to? Can someone tell me if I'm here? I will label this function call by number 1, 2, 3, 4, 5, 6, and 7, right? Function call 1, 2, 3, 4, 5, 6, and 7. If I'm done at function call number 1, what function do I return to? If I finish with 1, I'm going to go back to what function? 2, right? It eventually will go back to 7, but the first step is I go back to 2, I finish 2, go back to 3, finish 3, go back to 4, finish 4, go back to 5, blah, 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 right? It would keep going up, but it would go up one step at a time. And this can be super, oh, think about it, it's annoying, right? Why can't I just go back to 7? I'm done. I know the result, right? So to eliminate this long chain call, you can use exception to jump right out. When you're done at number 1 here, throw exception. You can do that, right? So here's what you can do. Basically, this is kind of, I would say it's a hack, to be honest, because the program are not designed that way. But this is the exact same function I showed earlier, but we use a technique to throw an exception. We do this, throw found index. Throw found index. And we use try catch right here, right? We try to call iter find. What do we want to catch? What do we want to catch? Yeah, it's a life hack. So in this case, what do we want to catch? We know that once we found the location, right, we're gonna throw exception called found index. So you want to catch for that exception found index, right, with the input location, and you return that location. That's it. You actually now jump from that deep function call all the way back, right? Okay, so actually, that's it for today's lecture part, right? We'll move on to the in-class exercise part. But before we leave today, there are a few things that I want to actually, I guess, tell you about collections, about things that are related to admin stuff that we have to talk about. So collection can be extremely versatile, especially in a modern functional language like Scala, right? Scala collections come with a bunch of library. For example, if we assume val L is the list of 1, 2, and 3, you can do L.length to get the length of the list. You can do L.access with the predicate to check if the matching predicate exists. Basically, you can look up Scala library, right? If you want to use the library for list, you can go to Google Scala list library. It would show up the web page that contain, okay, these are the function calls you can call with the built-in list implementation inside Scala. You can map a function to all elements using a map function. So we're gonna learn this map in I think in detail in the second half of the class when we talk about parallel program. The reason why map is really good for parallel program is a lot of times when you do this mapping, you can do all of them in parallel, right? So hopefully you're excited to learn all these things. We'll definitely cover that. You can filter out elements. Again, this is also really fast code as well. It can be done in parallel. You can add a bunch of them. You have a list, you can do L.sum. It will give you the sum of the everything in your list. You can drop in elements. You can have a lot of more things you can do. There's a Scala doc, which is the documentation for Scala. It includes all the explanation of what will happen if you call these certain APIs, certain libraries that are available for you in Scala. Quick caveat, feel free to use anything for your project, but for your homework, please make sure that you abide by the rule of the homework. So check carefully. Each question has some restriction because we want to make sure you practice certain things from each of the questions. Then I want to make sure we don't have additional in-class exercise today because I figure you still are working on the in-class 2 to 5. Last time when we do the after hours in-class exercise, not after, but after lecture in-class exercise, I think you're still on, most of you are still on in-class 3 and 4. So keep it up, implement these zip and unzip function. And one more thing, and we'll do a vote right now, which is the makeup class. Remember the earlier in this month, I think the third class we have to cancel that because it's a public holiday. So we need to make up a class. Yes, I will. I'm so sorry about that. The video for lecture 4 onward will be uploaded. I actually forgot. I'm sorry. They will be uploaded. So we canceled the class on May 4th, and basically I look at all the polls and schedules so far. I would like to propose to make up a class on one of these 3 slots, right? May 24th, May 31st, and June 2nd. All of them are noon to 2 p.m. So which day works best for you here? Can you put in I'll put in a vote on WebEx right now. And while I'm making a vote, feel free to ask questions if you have any. And I'll stop the recording for now so that I can post the video later, right?